Welcome, Honors Algebra 2, to our 6-1 video. So we are going to start chapter 6, which is our trig section, and this is 6-1 angles and their measures. And it's something that is pretty straightforward. It's nothing too crazy, but it's just kind of introducing you to how we measure angles and the different systems or the different units that we use to describe angle measurements. So first thing, we use the symbol, and it's a circle with a line through it, which is the Greek symbol for theta. And you might have seen this in geometry. So we use the symbol theta to represent an angle measure. So you'll often see, like, within an angle measure itself, we'll draw like a theta, and that's just saying, okay, here's your angle measure you're looking for. So an angle in standard form is an angle with its vertex at the origin. And we'll draw what I mean down here. So the units used to describe angle measurements are degrees and radians. So degrees and radians are essentially the same exact thing. It's just different ways of representing the same thing. So it's like feet versus yards. You know, it's like metric system versus whatever we use here. It's not different values. I mean, it's different values, but it's just a different way of measuring something. We often will use radians in this unit. So that's kind of where we're at here. So let's look at an angle in standard position. So we're going to be drawing a lot of angles within a graph context. And so an angle in standard form is an angle with its vertex at the origin. So the vertex of an angle, actually, let's just draw an angle to start with. The vertex of an angle, if I were to draw an angle here, and that's saying from here to here is my angle measure. So there are parts to this that we would label. So this side right here that's starting along the x-axis, that is called my initial side. And then this side that it's ending at is called my terminal side, because it's the ending side. And so then the vertex is where those two sides meet. So it's like the middle of the sides. And so that is my vertex. So like I said, we are often going to be looking at angle measures within a graph context. And so we often look at them also within degrees, like the graph within degrees. So if this is 0 degrees, we know that, okay, this is going to be 90 degrees. That from here to here is a right angle, which we know a right angle is 90 degrees. If we keep going, we add 90 degrees, that's 180. We add 90 more, that's 270. We add 90 more, it's 360, which makes sense. A full circle, because we end up back at the same spot, is 360 degrees. Now, if I were to estimate this angle, I would say, okay, it's half. It looks like it's about halfway in between 0 and 90. So we can estimate this to be about 45 degrees. So a counterclockwise rotation, which this is counterclockwise, right? A counterclockwise rotation results in a positive angle measure. So we're going to be dealing with both positive angle measures, and then we're going to look on the next column, and it's going to be negative angle measures. So a clockwise rotation, so if I'm going in this direction, is going to result in a negative angle measure. So let's look at that and draw it out. So I'm actually going to draw the same angle. And so that's going to be from here to here. But instead of going counterclockwise, what's going to happen is my angle measure is going to be from here to here. Now, this is still the initial side. This is still the terminal side. This is still my vertex. Nothing changed there. But now when we're going in the clockwise rotation, this is still 0. But now if I'm going in this direction, this would be my negative 90 degrees. And then this would be negative 180. And here would be negative 270. And then now back here would be negative 360. So if I were to estimate what do I think that my angle measure would be, it would be approximately negative 315 degrees. That's because we know, okay, this is about halfway in between. If we're going off of this information, same angle, I know it doesn't look exactly the same, but if we're assuming it's the same angle measure, we know we went 90, 180, 270, and then we went another 45 more. So 270 plus 45 gets me that negative 315. And it's negative because we went in that clockwise rotation. We're going to be going through negatives and positives a lot throughout this entire unit. So just kind of knowing how to draw them and see them right now is what's important. So the next thing we're going to be talking about is conversions. So converting degrees to radians or vice versa. So 180 degrees is equal to pi radians. And this is super, super important. It's something I would say to memorize and have that down because we are going to be converting back and forth from degrees to radians often. So let's do some examples. So we have degrees and we want to convert to radians. So I'm going to set it up just like you would if you were taking a chemistry class. So you have 125 degrees. Now you're trying to get rid of the degrees. So that means I'm going to put the degrees on the bottom because 180. And then I'm going to put radians on top. So pi radians, because that's what we want our end result to be. So what the end result is going to go on top, and what you're trying to get rid of is going to go on the bottom. So then what I would do is I would just do that math in my calculator. So we're going to ignore the pi for now. And so we're just going to do 125 divided by 180. Now, I do not want you guys to write it as a decimal. Radians should always be written in fraction form. So then what we're going to do is convert it to a fraction, and we're going to simplify it. So remember, our calculator does that if I press math and then frac. And so 25 over 36 would be my simplified fraction. So my answer here would be 25, bring the pi back in, over 36. And that would be my final answer written in radians. So one thing I want to note about radians. So radians should always have the pi, oops, went through the paper, left in the answer, typically. In ours, you will. And should always, or should be written in fraction form. So, two things of what that means. The pi, basically what that's saying, leave the pi there, don't multiply it out. So don't multiply 25 by 3.14, da, 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 da. And then always should be left in a fraction form. So you shouldn't be writing radians in a decimal form at all. Okay, so what I want you guys to do is try and pause me right here and then try number 2 on your own. So pause and do 2 on your own and then come back and check your work. Okay, so hopefully you're checking your work. So we would be taking degrees and converting it to radians. So that means we're trying to get rid of degrees. So 180 degrees is equal to pi radians. And so we, again, just do that in our calculator. You can do it in your head too. I think a lot of you guys can simplify that in your head. Divided by 180. Oh, sorry. And then convert it to a fraction in its simplest form. So 8 over 9. So that means my answer is 8 pi over 9. And that would be the same thing. So 160 degrees is the same as 8 pi over 9 radians. Okay, so negative 60 for number 3 doesn't change anything. We just keep the negative there. So we're trying to convert this to radians. So we're trying to get rid of degrees. So put the degrees in the denominator and the radians on top. And so again, we just can do that in our calculator. Negative 60 divided by 180 gets us a fraction of negative 1/3. We don't have to write the negative 1. We can just write it as negative pi over 3. Because negative 1 times pi is just negative pi. Okay, so go ahead and try 4 on your own and then come back and check your work and see how you did. So pause me here and try 4 on your own. Okay, so I did my work here. I got negative 204 degrees is the same as negative 17 pi over 15. So that does it for converting from degrees to radians. So if you guys have any questions, please make sure you guys are bringing them to class on Monday and we can go over any questions that you guys have. But the next set of examples is just doing the opposite, converting from now radians to degrees. So 5 pi over 3 is in radians, and now we just need to convert it to degrees. So what I'm going to do is 5 pi over 3. We're trying to get rid of radians. So pi is going to go in the denominator, and we're trying to convert it to degrees. So 180 is going to be going on top. We're always using this as our conversion tool. Pi over 180 is used every single time. It just flips depending on what you're trying to convert to. And then what happens here, well, the pi's are going to cancel out. Pi divided by pi is 1. And then what I do is I would just, in my calculator, do 5 times 180 and then divide that by 3. And we get 300 degrees. So a lot of this is just kind of calculator work and knowing how to use your calculator. Okay, so try 6 on your own. So pause me here and then come back and check your work for number 6. Okay, so hopefully you're coming back to check your work. Again, we're converting from radians to degrees. So that means we're getting rid of the radians, which means it goes in the denominator, and we're converting it to degrees, so degrees goes on top. So the pi's, just like before, cancel. Pi divided by pi is 1. And then in my calculator, all I'm going to do is do 7 times 180, which gets me 1260, divide it by 6, and I get 210. So my answer is 210 degrees. Okay, so then we're on to 7. So again, just like up above with 3 and 4, the negative didn't change anything. So all we're going to do is we are going to convert what we have, which is in radians, to degrees. So that means if we're getting rid of radians, radians is going to go on the denominator, and then degrees is going to go on top. So the pi's are going to cancel. Pi over pi is 1. And so then we can just multiply using our calculator. Negative 5 times 180 gets me negative 900. Divide by 4, I get negative 225. That's my answer. So far, so good. Okay, so what I want you guys to do is try 8 on your own. I'll give you a little hint. It is going to be a decimal, which is fine. When we're writing things in degrees, we can write it as decimals. What I want you guys to do is round it to 4 decimal places. So try 8 on your own, round it to 4 decimal places. Yes, 4. So we're going to get in the habit of rounding to 4. Okay, so try 8 on your own and then come back and check your work. Okay, so you should be checking your work. I got negative 257.1429 degrees. Now, you are rounding to 4 decimal places. So when we look at our calculator, because sometimes we have issues rounding, we look at the 5th value, which is 5. Remember, 5 or higher, we round our number up. If it's 4 or below, we keep it the same. So because it's 5, we round that up to the 9. And that's it. So that is your notes for today. And there you have it. If you guys have any questions or if you need any help or any clarification, please bring it to class on Monday so we can go over it and talk about any questions that you guys have. Hope you guys have a great weekend, and I will see you soon. Bye, guys.